This video shows initial processing steps for tripod-mounted scanner data, including removal of window reflections. The dataset is courtesy of City of Jyväskylä. We have 41 scans, which are already georeferenced, so we don't have to do anything to the XY set of the points. We're going to read the data in, deduce scanner positions, remove long distance points, cut overlap, run thinning to 1 centimeter spacing, and then we create wall polygons for the purpose of classifying window reflections using those wall polygons created. In mobile data and in tripod-mounted data, we often have window reflections. So the laser pulse travels the path of the red and the yellow, but the system thinks it has traveled the red plus green path. And then we get images of objects at false locations, ghost images of trees, cars, building walls, and so on. First, I'm going to read in the point cloud. I have 41 files. The file names start with a scan number. I'm not going to read in every attribute. I can't see any use for amplitude, angle, or scanner, so I'm going to leave those out. And I'll assign the first number from the file name as a line or scan number. And I have 419 million points. First, I'm going to classify those into the default class. Then I'll check that the line coloring shows that each scan is its own line. The scanner positions show up as somewhat circular holes in one color, one scan. I do have multiple returns recorded. I see some first of many, some intermediate, some last of many. And when the points are in the scan order and I have multiple returns, then I can, in deduce scanner positions, use multiple echo vectors, which computes a vector between the first, second, or first and third return, and from the intersection of vectors derives scanner positions. And now I'm just checking that each scanner position falls into a hole. So I have the scanner positions deduced using a method that gives me accurate scanner positions. Next, I'm going to remove very long distance measurements. I'm going to classify everything which is more than 100 meters away from the scanner into its own class 7 low point, which I plan to delete from the dataset. Next, I'm planning to do cut overlap. Remove longer distance measurements when there's shorter distance measurement on the same spot. I'm looking at one building wall. I feel like I didn't get the direction of the cross-section exactly right. So I go in and I do a little bit of rotation of the cross-section. And I do have multiple scans, many different colors on this wall surface. Blue color dominates. It's the closest scanner position. And the surface is noisy. So I will run cut overlap, which removes the longer distance line points if there's a line or a mesh scan which has seen the same spot from a shorter distance. Those points are now in class 12. If I hide that class, I see a cleaner surface. And with the overlap, it's more noisy. I'm going to delete all the overlap points, the long distance measurements. And I have big differences in the point density. I'm going to do thinning, which mainly with 1 centimeter spacing is going to do removal of unnecessary density from the spots close to the scanner, where the density is much higher. But majority of the data is more than 1 centimeter point spacing. Now I have 148 million points. Now we take a look at how much do I have window reflections. I see an image of a tree inside a building. I will use inspect point to view the pulse vector of the point closest to the mouse. And the points which are forming a tree inside a building, they are all measured from outside the building. The pulse vector goes through a window. So these are window reflections. And we do have window reflections both inside the buildings and also outside the buildings. I'm going to create polygons for walls for this purpose. I don't need to do it for points far away, so I temporarily classified everything more than 50 meters away from the scanner into class 6. I decide on a level and color to which I want to create polygons with Vectorize Wall Polygons tool. This searches for any vertical wall-like surface in the point cloud and creates polygons for the places, groups of points forming one planar wall-like surface. Many of the polygons are going to be real walls, but there's also going to be sides of bigger vehicles, fences, and simply other structures. And sometimes what we find as a wall is really a window reflection of a wall. So I don't want to use every one of the polygons created. I'm going to delete anything which is clearly outside a building, that it's not a building wall, it's something else. Often it's the side of a van. Also inside buildings, if I see a polygon, it is often a window reflection, and it is typically not going to be useful in our task. So majority of the things inside the buildings I do want to delete. So I'm going to spend some time removing the unnecessary polygons for our task. I only need polygons for building walls where there's window surfaces. Here I'm removing what are really fences. There's a lot of playing fields for football or tennis, and those fences do not have glass surfaces. I can remove all the findings which are really fences. Checking the wall polygons is a significant effort, and I do want to remove as many as I can before I start spending more time on each polygon. And things inside the buildings are usually window reflections, or even if they are real wall surfaces on a higher level in a building, they are not typically needed for removal of window reflections. And I keep removing polygons which I believe I don't need, or which are most likely window reflections inside a building. And I'm going to select all of the polygons, and I'm going to use Inspect Elements tool, which gives me an organized way of viewing each one of the selected polygons. And I want to create a plane section view. That gives me a section view where the active depth plane matches the polygon surface. And I want to have an action button called Accept, which accepts and modifies the element level and color. And I want to have an accept or an action button which rejects and simply deletes the element. So on every polygon I decide if it's good or if it's bad. If it's bad, then I may draw a better polygon myself. In view number 2, the section view, I'm going to use depth coloring and highlight plane setting. It will draw points within 5 centimeters of the active depth plane in color. Points more than 5 centimeters from the active depth plane will be displayed in grayscale using depth. The first polygon I accepted. It looked good to me. The second one, I don't like the rectangle the software gave me, so I'm going to draw a polygon which better matches the wall. What I need to have is polygons which have all the windows inside, but do not extend outside the wall. Quite often I'm doing more careful work than what the window reflection task really calls for. But I feel like I may benefit from the polygons in some other way, that maybe it's a good idea to create good polygons for the building walls whenever it doesn't take too much time. If I don't like the polygon, then usually I place a new polygon, either with place block or place shape tool. And when I have placed a new polygon, then I recheck to delete the automatically created polygon. If the polygon looks good, then I just accept. Green indicates that the points match the plane, the active depth plane, very, very close. And red color, blue color mean that the points are close to 5 centimeters off the plane. When I'm going to classify window reflections, I'm going to use a tolerance of 50 centimeters. So it is okay if my polygon does not match the points at the level of a few centimeters. On some of the wall surfaces, the scanner has seen only part of the wall surface. And I decide what kind of a polygon I create. The important thing is that the polygon has all the windows inside and does not extend outside the actual wall surface. I have speeded up the recording so that I don't show the handling of every polygon. There was 157 polygons, and it took me half an hour to go through this. And it is a significant amount of effort, but it is my best strategy for getting rid of the window reflection points. There's millions and millions of those, and they are tricky to find. And this is now my last polygon. Here again I want to draw a polygon which should enclose all the window glass surfaces on this wall. Now I have completed the creation of polygons, and then I can classify any points where the pulse vector travels through a polygon, and the point is more than half a meter behind the polygon surface. So I will classify from default into low point glass, and then I have 6 million points classified as window reflections. And I will do a check to make sure that it is really stuff inside buildings, window reflections that have been classified, and not something which is good, valid data that I would like to keep. Here I'm looking at some points which are window reflections outside a building. In this area I have quite a lot of coast images of trees outside a building. And I may use inspect point to check that it is really a case where the pulse vector goes through a building. So it is window reflections, not a real tree. So I'm not really seeing anything that I would like to keep. Here I'm looking at one example where there is a very convincing looking point cloud of a tree outside a building. But all the points have pulse vectors which come from the other side of the building. So it is a ghost image of a tree. So I think I'm going to be okay deleting all the points classified as window reflections. And then I have a much cleaner point cloud to start doing the actual real classification of the point cloud. And I will save my point cloud as all scans filtered.fbi. Thank you.